Hello students, in this video we'll be discussing the Cbse class 10 NCERT textbook first chapter, that is real numbers. In this real numbers we'll be discussing the theorem 1.3. So this theorem 1.3 is an important theorem and we have some questions based on this regarding rational, irrational and all. In the previous video I have discussed about the types of real numbers. What is a rational number, what is an irrational number, and the types of rational numbers. So all that I had already discussed. In this video we will learn about the theorem 1.3. First we look into the statement. Let P be a prime number. So we are considering P to be some prime number. Okay, and they are telling that P divides A square. So here what they are telling is P divides A square. What is the meaning of P divides A square is what we need to know first. So if we know the meaning of this, the rest of the theorem is going to be very easy. We would have learned the sentences telling divide this by this or this is divided by this. Okay, but this word P, the sentence P divides A square might be new to you. So this is nothing but, or this is similar to the statement A square is divisible by P. A square is divisible by P. So that you will know. If you say that A square is divisible by P, it means that if you are going to divide A square by P, then you will have the remainder to be 0. So that is what is our understanding with what you've learnt in your lower classes. So here they are telling that P is dividing some A square, then P is also going to divide A. Okay, and they are also telling that P is a prime number. So let me consider the value of A to be some value 10. Okay, if I want to find out the factors of 10, I know that the factors of 10 are 2 and 5. Okay, so A is going to be 10 and the factors of 10 are going to be 2 and 5. Let me take this to be P1 and this to be P2. Okay, when I'm going to consider this as P1 and P2 and this as A. So here they're telling P divides A square. So I'm taking either of the P, either P1 or P2. Let me first take P1. Let me consider like P1 is dividing A square. Okay, P1 is dividing A square. I have 10. So let me consider it to be 10 square. That is going to be 100. A square is what? 100. So P1 is going to divide 100 up. Now what is the meaning? When you divide 100 by P1, that is 2, then you will get the remainder to be 0. Yes, we all know that. So when you are going to multiply it with 50, you will be getting 100, so the remainder will be 0. Yes, you can divide 100 by P1. So this is going to show that my P1 is dividing A square. Okay, the next one is what? P2. Let me consider with P2 also. Does 100 will 100 be divided by 5 also? Yes, we can divide it by 5. You will get it as 20 and again you will get the remainder to be 0. So you can say that 100 is divisible by both P1 and P2. Okay, so that is A square is divisible by P1 and P2. That is what we are telling here. P divides A square. Now the next statement is then P divides A. P divides A means what? 10. So that we already know that even for 10 you are going to see that 2 and 5 are going to divide. Okay, so P will divide A square, then P divides A. Under what condition? When A is going to be a positive integer. I already told you yesterday what is a positive integer, what is a negative integer, all that we've discussed in the previous video. Okay, so let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. This is what we have. Okay, so I can say that A is going to be product of the primes. I can write any number as product of primes. So here I can tell it to be A is 10 abdina, it is going to be product of primes P1 and P2. Okay, if I am going to take A square for 100, if I have to divide it, okay, for 100, if I am going to find out the prime factorization, check this method. So you will have 2 5s are, so 0, you will have 2 25, you will have 5 5s are 25, and then 5 and then 1. So what are you getting here? You are getting 2 and 5 once, and you are getting 2 and 5 another time. So I can say that I am getting 2 square into 5 square, or I can say P1 square into P2 square. So A square is written as P1 square into P2 square. So that is what we are going to see in the proof. Now let us look into the proof line by line. Let the prime factorization of A be as follows. We know the prime factorization of A, that is going to be for 10. So for 10, what can we do? We can do it as 2 5s are 10, 5 1s are 5. So that is what P1, P2 and so on till Pn, depending on the number it will change. Okay, where here we are saying that P1, P2 all are primes because we are doing it by the prime factorization method and not necessarily distinct. That means what? It can change. Okay, if I am going to do it for 4, okay, if I am going to consider the same thing like if I am going to consider A to be 4, then when I do the prime factorization I will get 2 and 2. Okay, so where I can say that they are not distinct. Okay, they are not different, they can be repetitive. Okay, so that's why the word not necessarily distinct is given. So when A is equal to all the product of all these primes, then A square will be the square of the product of the primes. Okay, that we had already proved here. So likewise, if I am going to take it for 4, if I am going to take the square of 4, A square, so it will be what? 4 for the 16. So what will be 16? When I do prime factorization, I will get 2 8s are, 2 4s are, 2 2s are, 2 1s are. So what will I get here? I can write it as 2 square into 2 square. So here I wrote it as 2 into 2. So again see I am getting the product P1 square into P2 square and so on till Pn square. So with this we are able to, we have already given that P divides A square. So if P divides A square, then from the fundamental theorem, so already you would have discussed the fundamental theorem of arithmetic also, which is so fundamental arithmetic theorem of arithmetic says that every composite number can be expressed as a product of primes. Any composite number can be expressed as a product of primes. That is what we've seen here. The numbers which we have taken are all composite numbers and they are expressed as a product of primes. So according to it, P is one of the prime factors of A square. Yes, P is one of the prime factors of A square. So what is this P here? Though we have written it as P1, P2, P3, P is one of the P1 or P2 or P3. However, using the uniqueness part of the fundamental theorem of arithmetic, okay, so what is this uniqueness part of it? If we see, it is nothing but, and this factorization is unique, okay, apart from the order. So this order is not required. It is unique that only the prime factors of A square are P1, P2 till Pn. So prime factors are only, that is, we will take only the 2 here. We will not take it as 4 because 4 will become composite. Okay, so even when you are writing A square as product of the squares also, we will take it to be 2 square into 2 square. You can't take it as 4 into 4. So then you cannot say it to be product of primes. Okay, that is the uniqueness part of the fundamental theorem of arithmetic. If you need to brush upon this, you can see this fundamental theorem of arithmetic in page number 8 in your textbook. Okay, from this we are able to realize that the prime factors of A square are what? P1, P2 till Pn. So P is nothing but one among the P1 or P2 or P3 or anything. Okay, so now with this we are able to see that since A is equal to P1, P2 till Pn, P divides A. So from this we are able to prove that P will also divide A. So we are first seeing the first part is the given data. What is given? the given data is that P is dividing A square. If P can divide A square, then P will also divide A, provided that A is a positive integer. Okay, so hope you understood this theorem 1.3. So based on this theorem, that is based on the statement of this theorem, we will be proving why few numbers are irrational. So that we will be doing in the next video. Okay, so hope you understood this, children. If you have any doubts, please go through this video again and again so that you will get a clarity over this. So see you again in the next video. Thank you, children.